Okay. Gary, would you like to lead us off?
I'm going to. I was just going to wait about another 30 seconds because I'm hearing people. I'm hearing pinging as people are coming in. That's all. We'll start after one more ping. How's that?
Fine.
We should get started. First of all, welcome to everybody who's joined the NNECTR seminar. I really want to begin by expressing appreciation to Dr. Doug Lowy for, again, joining the NNECTR seminar group to be able to provide an update on where we are with the HPV vaccine and where we are with HPV vaccination. I need not go ahead and say anything about the importance of the HPV vaccine, because this is really something which emerged from Dr. Lowy's laboratory and provides a striking example of how you could take laboratory-based discovery and translate it directly into cancer prevention and control. And the impact has been enormous. Well, for the past 2 or 3 years, the focus has really switched to a significant extent from prevention and control to survival. So I think it's really important to hear about where we are in terms of the vaccine and and vaccination, some of the initiatives that are being taken to try to restore understanding of the importance for prevention of HPV. I think it's also important to express appreciation to Doug Lowy, not just for what he's done in terms of developing a vaccine, which is really, really a key and is becoming all the more important as time goes on, but also for the leadership that he's provided for the National Cancer Institute. So, Doug, thank you so very much for what you've done, and thanks again for joining us. I'm going to go ahead and ask Dr. Andrew Fritz to introduce Dr. Lowy.
Hello, as Dr. Stein said, I am a faculty scientist in the Stein Lab, and as a housekeeping measure, just make sure that if you have any questions, please put them in the chat, and they will be held for the question and answer session for the end of the discussion section, and that'll be led by Dr. Katie Moidel. So she can introduce herself now.
Hi, everyone. I'm Katie Model. I'm an associate professor at the Maine Health Institute for Research, and I'll turn it back to Andy.
Okay, so Dr. Lowy, MD, is the chief of the Laboratory of Cellular Oncology, and since 2010 has served as a principal deputy director of the National Cancer Institute. From April of 2022 to October of 2022, he became the acting director of the NCI, a role he also held from April 2015 to October 2017, and between April 2019 and October 2019. Dr. Lowy received his medical degree from the New York University School of Medicine in 1968 and trained in internal medicine at Stanford University and dermatology at Yale University. He has directed a research laboratory at NCI since 1975 after receiving training as a research associate in the National Institute of Allergy and Infectious Diseases. Dr. Lowy is a member of the National Academy of Sciences and of the Institute of Medicine of the National Academy of Sciences. And for his research with John Schiller on the technology that enabled the preventative HPV vaccines, they have jointly received numerous honors, including the 2007 Federal Employee of the Year Service to America Medal from the Partnership for Public Service the 2011 Albert B. Sabin Global Medical Award, the 2012 National Medal of Technology and Innovation, awarded in 2014, the 2018 St. Georgi Prize, and the 2017 Lasker DeBakey Clinical Medical Research Award, the country's most prestigious honor for biomedical research. Dr. Lowy has received the National Medal of Honor for Basic Research from the American Cancer Society and is a fellow of the AACR Academy. And with that, I'd like to hand it over to Dr. Lowy. Thanks so much.
Andy, thanks so much for this really kind introduction. I'm delighted to be here today to talk with everyone, and I'm hoping that there will be plenty of time when I finish my formal presentation for there to be time for discussion. And in addition to asking questions, feel free to tell me about things you disagree with me about when I make statements or et cetera, so we can have a vigorous and informative discussion. If I could have the next slide, it's my disclosure slide, which really just tells you, as Andrew was saying, the NIH has patents on the vaccine technology, and I am an inventor, and the technology has been licensed to the two companies that have the FDA-approved versions of the vaccine. I will discuss a potential off-label use of the FDA-approved vaccines, which is fewer vaccine doses. I am not recommending that at the current time. And I have been the inventor of a number of other technologies which have been licensed to a wide range of companies, but are not directly relevant to today's presentation. I'm largely going to tell you about good news. That is, first, that the vaccine is having a substantial impact in the United States and elsewhere. That despite COVID, vaccine uptake has been quite remarkable. And in your area of the country, HPV vaccine uptake has been quite good. That doesn't mean there isn't room for improvement, nor does it mean that we shouldn't worry about backsliding. But really, I think that the message is quite positive. I also have included a few slides about some comparisons between SARS-CoV-2 or COVID infection and the SARS-CoV-2 vaccines and the HPV vaccine, because this is a question that might come up for you, when you're seeing patients and in other situations. So if we could have the next slide, Sheila, thanks very much. I want to set the stage that there are 3 HPV vaccines that have been FDA approved. Gardasil 9, which is the third one, is the only one that currently is available for sale in the United States. But Cervarix, made by GlaxoSmithKline, and Gardasil, which is the quadrivalent vaccine, are approved by the FDA, but no longer available in the United States. As the photomicrograph below indicates, the HPV vaccine is composed of virus-like particles, and we think that this endows them with properties that make them quite favorable as a vaccine. And I want you to pay attention in this slide to the HPV 16, 18, and then the 5 additional HPV types, not to memorize the numbers, but to see that there are kind of 2 components in addition to 6 and 11. 16 and 18 is what was in the first generation vaccines, Gardasil and Cervarix, whereas the 31, 33, 45, 52, and 58 are in the second generation vaccine, Gardasil 9, and HPV 6 and 11 together are responsible for about 90% of genital warts. Next slide. This slide is taken from the CDC, which depicts for you the total number of HPV-associated cancers per year in the United States, a little over 35,000, and usefully divides them with the darker blue, the proportion or the number that are attributable to HPV 16 and 18. In the lighter blue, the proportion or number attributable to the additional 5 HPV types present in Gardasil 9, and the white are those that are not caused by HPV types, not specifically targeted by Gardasil 9. And what I want you to appreciate first is that there are several different cancers that are attributable to HPV infection. And of course, there are differences between women and men, with cervical cancer predominating for women and oropharynx cancer predominating for men. HPV 16 and 18 responsible for most of them, but particularly for cervical cancer, the addition of the 5 types in Gardasil 9 gives additional protection that is specifically targeted. The next slide shows you that in the world, there are some major differences between what happens in North America, which is shown in the open blue rectangle on the bottom, where we have a relatively low incidence of cervical cancer, which is in blue on the left, and even lower incidence of mortality. Okay, the mortality rates are quite low. But if you look in the upper red rectangle on the top, incidence and mortality in Africa and in other areas of the world, in low and middle income countries, much, much higher. In addition, as the first bullet point notes, about 90% of cervical cancer cases and deaths occur in low and middle income countries. And cervical cancer represents about 90% of HPV-associated cancer in low and middle income countries. So that's qualitatively different from what is seen in the United States, where there's much more heterogeneity of different cancers attributable to HPV infection. Next slide. And this slide is one of the slides where I'm trying to highlight some differences between HPV and SARS-CoV-2. If you look on the left, HPV disease is caused by several different HPV types, whereas on the right, SARS-CoV-2, there's a single SARS-CoV-2 type. In addition, HPV is a DNA virus, and the viral genome rarely mutates. By contrast, SARS-CoV-2 is an RNA virus, and the viral genome commonly mutates. The third bullet point is viral variants within a single HPV type are closely related immunologically, whereas as shown on the right, and we are all painfully aware, viral variants, even though they're within the same SARS-CoV-2 type, they may be distantly related immunologically. So protection against one will not necessarily confer protection against the other. Next slide. So we're very fortunate when it comes to cervical cancer and the other cancers. We have HPV vaccination, which is primary prevention against all of the different cancer types. Cervical cancer screening, which is for secondary prevention. And coming soon, I imagine, will be anal cancer screening, because recently there was a positive outcome for a large multi-center trial that NCI sponsored called the Anchor trial. And the positive results were published in the New England Journal of Medicine a few months ago. Joel Palevsky was the principal investigator and the main author of that. And so I look forward to the CDC really at some point in the near future saying that anal cancer screening will also be available, at least for a subset of patients who are at high risk of developing anal cancer. And then we have treatment of invasive cervical cancer, but also treatment of other cancers. And if the cancers are caught early, many of them can have a good outcome, but it's far preferable to have primary prevention or secondary prevention, which is based usually on dysplasia for the secondary prevention rather than on invasive cancer, because then you can protect against the development of cancer in almost all patients in whom dysplasia is detected. Next slide. So although we're going to focus on vaccination for the rest of the presentation, I do want to show this slide because the modeling indicates that if we could scale up screening to 90% coverage, we would actually get a decline in incidence and mortality from cervical cancer much faster than if we were to scale up vaccination. So although we're not talking about cervical cancer screening, I just want to highlight it's a very important modality for women who are eligible for screening, which is really all women over the age of 21 until 65, as long and they no longer need to be screened at that point if they have been negative for a few times. Next slide. So what are the goals of vaccination? And I see the goals being twofold. One is to directly reduce the risk of infection and disease in vaccinees. And the second is to indirectly reduce the risk by reducing the prevalence of HPV vaccine types, that is, the types targeted by the vaccine. That reducing the prevalence in the general population, what is usually referred to as either herd immunity or herd protection. And I will show you that in the United States, we have substantial herd protection already, despite initial relatively low uptake of HPV vaccination. Next slide. But then also, what are the goals from a public health point of view of HPV vaccination? And I would argue that they're different in less developed countries compared to more developed countries. In less developed countries, it's mainly to protect against cervical cancer, because as I pointed out, that's the cancer type that predominates over all others. And female vaccination would be most cost effective. In more developed countries, we want to protect both males and females against a wider range of HPV-associated cancer. And although female vaccination is most cost-effective, adding male vaccination can confer even greater protection for vaccinees than herd immunity alone. And most important for male vaccination, it's by far the fastest way to reduce HPV prevalence in men who have sex with men. Next slide. So this slide simply looks at the safety of the vaccine. And this now is from a review that was made 10 years after the vaccine was approved, and there really haven't been any showstoppers, in terms of side effects. So I think that that's something to really keep in mind. The safety record of the HPV vaccine has been similar to that of other widely used vaccines. Next slide. In terms of impact, these were some of the important initial vaccine results. The initial vaccine studies used 3 doses over 6 months, and the reason that it was 3 doses was there was no precedent for an effective vaccine against a local sexually transmitted disease, which is what HPV infection is. The vaccine has very high efficacy, and in principle, it can protect against the vast majority of cancers attributable to HPV infection, but it's largely protecting against the HPV type specifically targeted by the vaccine. The vaccine confers sterilizing immunity in most vaccinees. That is, it prevents infection in most vaccinees. The vaccine, however, does not treat established infection, and that's why it's so important to give the vaccine ideally in people before they become sexually active, because the data are very clear that relatively soon after establishing sexual activity, people become infected with HPV. And so in order to protect against that, you want to vaccinate people before sexual debut. Next slide. And there have been data now from several countries that had initial widespread uptake of the vaccine, that the vaccine actually prevents cervical cancer, which is the principal target of the vaccine when it was first being developed. And just shown in the green oval on the left, the incidence in Denmark among vaccinated women, if they were vaccinated when they were 16 years or younger, was close to 90% less compared to the non-vaccinated control population in the women. And these are simply the women who chose to be vaccinated or chose not to be vaccinated. If you look all the way on the right, the women who were vaccinated when they were 20 or older derive virtually no benefit in terms of protection against cervical cancer. That's not to say that they don't derive benefit, but using this outcome essentially 14 years after the approval of the HPV vaccine, there isn't benefit seen for that particular outcome. As the women get older, there will be, we can predict, some benefit against cervical cancer and against other cancers, but it's nowhere near as great as if people are vaccinated before sexual debut. Next slide. And this slide shows you what's happening in the United States. And this is data from the CDC. And the take-home message is that cervical dysplasia incidence has decreased in 20 to 29-year-old women in the United States between 2008 and 2016. The way that the data are broken out in this particular paper is women 20 to 24, 25 to 29, 30 to 34, and 35 to 39. And what's shown in the solid line on the left, if we focus on the 20 to 24-year-olds, is HPV 16 and 18 dysplasia. And you can see this really pretty dramatic decrease in the incidence of HPV 16, 18 associated dysplasia, a minor decrease for the other HPV types. If you look at the 25 to 29-year-olds, you can also see a gradual decrease over time for the HPV 16 and 18, and actually in the 25 to 29-year-olds, an increase in the dysplasia attributable to other HPV types. And the 30 to 34 and the 35 to 39, basically no associated decrease. So this specificity is almost certainly attributable to HPV vaccination, where uptake and the age of the women, you see much bigger benefit in 20 to 24-year-old women compared to 25 to 29-year-old women. And I just want to remind you, this is data through 2016. If we were to see data from today, I think you would probably see an analogous decrease in 25 to 29-year-old women to what is seen in 20 to 24-year-old women, but that's just speculation on my part. Next slide. And what about the decreasing genital warts incidence? And this is data from Kaiser Permanente in Oregon. And what's shown on the left is the strong vaccine recommendation for women led to a substantial decrease in anogenital warts in women over the next few years. And if you look at two other sexually transmitted infections, chlamydia and gonorrhea, there wasn't such a decrease. But if you now turn to the right side, the strong vaccine recommendation for males was not until 2011. And notice that you don't see a major change in anogenital warts in males until there is this strong vaccine recommendation. And that's associated with a substantial increase in the uptake of HPV vaccine among men. And you can appreciate that then over the next few years, a progressive decrease in anogenital warts without a concomitant decrease in chlamydia or gonorrhea. Next slide. So another disease that is relatively uncommon but important for the children who develop it is juvenile onset recurrent respiratory papillomatosis, which is caused mainly by HPV 6 and HPV 11, which are two HPV types present in Gardasil and also in Gardasil 9, and responsible for the majority of anogenital warts. And what I want you to appreciate here is that there's been a progressive decrease in the incidence of juvenile onset recurrent respiratory papillomatosis following the introduction of the HPV vaccine. And you can see even by the 2012 to 13 period, this substantial reduction. Part of the reason is that the children most at risk of developing this kind of respiratory papillomatosis are children who are offspring of women who are primiparous. It's their first pregnancy. If they are HPV positive and it's their first pregnancy, they are more at risk of transmitting infection to their offspring. And so that's why you see this impact, despite the fact that there was a relatively low uptake of HPV vaccine, even in the 2012 to 13 period. Next slide. This slide and the next one tells you a little bit about what I think are some really surprising good news about HPV vaccination during the COVID period. These data are from the CDC, and if you look at one dose or more, in 2019, in coverage for 13 to 17-year-olds, it was 72%. During the first year of COVID, it went up to 75%. And in 2021, it continued to increase, going up to 77%. Adolescents who are up to date with vaccination, 2 or 3 doses, depending on their age, is not as high, but it also continued to increase. And I I would speculate that the reason that this has we've continued to see it is that teenagers tend to go to the doctor before they go to school pretty much each year. And so they are interacting with the healthcare system, and they can be offered vaccination. It is not because HPV vaccine is required for school entry. There are very few states where that is a requirement. And this is looking at national data. And you see, I've highlighted in blue that urban areas have higher vaccine uptake than rural areas. So if we look at the next slide, this slide focuses on urban versus rural, poverty, below poverty versus at or above poverty, and also looks at what's happening in Vermont, New Hampshire, Maine, and Massachusetts. And the take-home message is with a comparison with the meningococcal vaccine is that HPV vaccine uptake is not as high as that of the meningococcal vaccine. But as I pointed out, it is higher than it was. In addition, there's higher uptake of the vaccine on a national level for children from families that are below poverty compared to children from families that are at or above poverty. And there is this substantial disparity between urban versus rural. And again, this is most striking if you look at the third line, at or above poverty, urban versus rural, where there's about a 10-point difference between the percentage of eligible teenagers who are getting vaccinated, whether they're in an urban location or in a rural location. And if you look all the way on the right, you look at meningococcal vaccine, there's a little bit of difference, but nowhere near as striking as what you see with the HPV vaccine. And then if you look at vaccine uptake in Vermont, New Hampshire, Maine, and Massachusetts, and this is for one dose, and you can just figure that there's about a 15 percentage point decrease for so-called up to date. Really, it's pretty good. Maine is a little bit lower than the other states, but it still is pretty much at the national average. And Maine is, we have to recognize, is a largely rural state. So this uptake, I think, is quite reasonable. If you were to look at, say, Mississippi, you would see something dramatically different where the uptake is under 55%, just to give you an example. Next slide. So I think this is perhaps the most important slide I'm going to show you today, which is the association of healthcare provider recommendation with increased vaccination uptake. And this is over several years. These are obviously they're observational data, but you can see easily a 20 percentage point difference in the likelihood of kids being vaccinated, depending on whether the healthcare provider recommends HPV vaccination or doesn't recommend HPV vaccination. Next slide. Just a word about mechanism of action. We think that the repetitive structure of the virus-like particle vaccine is what is responsible for inducing the high levels of durable neutralizing antibodies that confer long-term protection against HPV infection and disease. And this reconstruction electron micrograph shows you in blue what a vaccine particle looks like and what the virus-like particles look like. And this is a neutralizing monoclonal antibody that's bound to it. And you can easily understand how when these neutralizing antibodies are bound to the virus, it becomes difficult or impossible for the virus then to propagate infection in the vaccinee. Next slide. So this slide is a little bit complicated, but I want to go through it to basically give you two different take-home messages. The first is herd protection in 14 to 24-year-old women 12 years after vaccine introduction into the United States. So this goes through 2018. And so you can easily imagine that since uptake has increased and, with more time, that herd protection, if anything, should be greater. If you look at the darker blue for 2007 to 10, 2011 to 14, and 2015 to 18, the darker blue represent the unvaccinated women, okay? And what you can see is a stepwise decrease in the prevalence of the 4 HPV types in unvaccinated women. This is herd protection. And I'm not showing you the data, but when you look at other HPV types, you just don't see that. And you can go look in this paper to see it. The other part is shown with the diagonal line. If you look in the females who are vaccinated, this diagonal line shows you that only about 25% of females were vaccinated, fully vaccinated, 2007 to 10. It went up to about 50%, 2011 to 14, and to 60%. This is, fully vaccinated, 2015 to 18. And so you can appreciate that even by 2011 to 14, there is herd protection, although only about 50% of the women in this age range have been fully vaccinated. And the contribution of male vaccination during that time period is probably very small, because as you can see, it was about 15% fully vaccinated in 2011 to 14, and 2015 to 18, a little bit higher. So the take-home message is there is herd protection in the United States, and it can be achieved even with relatively low levels of HPV vaccine uptake. Obviously, higher uptake, more protection. Next slide. So I have two slides about some clinical differences between the HPV vaccine and SARS-CoV-2. The first bullet point tells you that vaccination prevents even benign infection in most vaccinees, whereas SARS-CoV-2, many vaccinees remain susceptible to mild infection. HPV vaccination readily induces herd protection. SARS-CoV-2 vaccination has not been shown to induce herd protection. The next slide continues this comparison. The HPV vaccine confers strong protection against all variants within a given HPV type. By contrast, the SARS-CoV-2 vaccine may confer reduced protection against some variants. And the last comparison is the vaccine induces more than 10 years of strong protection with fully vaccinated people, whereas the SARS-CoV-2 induces several months of protection. And that's why people need to be revaccinated with the SARS-CoV-2 vaccine. But once people have been fully vaccinated with the HPV vaccine, there's no suggestion that they need further boosters. Next slide. So my last topic is, might a single HPV vaccine dose confer years of protection? And this is what is not yet standard of care. And so I'm not advocating it, but I want to show you, we think with our research that we're developing evidence so that a few years from now, this might become standard of care in the United States and globally. But as I say, this is speculation at this point. Next slide. So the problem is that worldwide control of cervical cancer requires worldwide female vaccination. And the current reality is that only about one eligible young woman in 10 in low and middle income countries get vaccinated each year. And we think that a possible partial solution would be single dose vaccination. But as I pointed out, it's not yet standard of care. Next slide. So our observational studies from our Costa Rica vaccine trial, which is post hoc analysis, is that one vaccine dose prevented HPV 16/18 infection as effectively as 2 or 3 doses when you monitor this even 11 years after vaccination. And 100% of the women who received one vaccine dose remained positive for HPV 16/18 antibodies 11 years after vaccination. Next slide. So we are conducting a long-term trial in Costa Rica of 2 FDA-approved vaccines, Gardasil 9 made by Merck and Cervarix made by GlaxoSmithKline. And we're comparing the efficacy of 1 dose versus 2 doses. And we hope that this trial will read out in the next couple of years. It has been delayed in terms of readout by COVID. But if the results are positive, we think that the Advisory Committee on Immunization Practices would then end up recommending 1 dose. But as I point out, it's not yet standard of care. Next slide. And this is my last slide, which is the summary conclusion. Basic research led to identification as HPV as the cause of several cancers and to the development of HPV vaccines. And although I didn't talk about it, molecularly based cervical cancer screening. Virus-like particle display is highly immunogenic and can induce herd immunity, durable protection, and prevent cervical cancer, as well as the other cancers attributable to HPV infection caused by these HPV types. And we think that control of HPV-associated cancer as a worldwide public health problem may soon be feasible. So thank you very much for your attention. And I really look forward to what I hope will be an interesting discussion. And as I say, don't just ask questions. It's fine with me to say, you know, Doug, I disagree with you on some of your points.
Okay, thank you so much, Dr. Lowy, for that exciting presentation. It's really fascinating to see the progress in the United States in contrast with, you know, what needs to be done still with the rest of the world. I'm going to ask everyone to please raise their hand if they feel like asking a question. We can certainly call on you. If you prefer, you could also write it in the chat, and we will monitor those as well. So let's see. Oh, we have one raised hand. Jan Carney, please go ahead and unmute.
Thank you. Thank you very much. I was intrigued by your slides that looked at meningococcal vaccine versus HPV vaccine, and it seemed to imply that there could be differences in how we think about these infections, or how the public thinks about these infections in terms of immediate risk or danger or long-term risk. Can you just any comments
Jan,
about?
Jan, that's a great question. I would suggest that you go and actually look at the MMWR, any of the recent years, because the CDC has a beautiful figure that shows the rate of uptake over different years of meningococcal vaccination versus HPV vaccination. And you're absolutely right. It's no longer, I don't think it's any longer a relevant comparison, because meningococcal vaccination over the last few years, there have been school entry requirements for it. But if you go back and you look at earlier years when there weren't school entry requirements for most states, you can see a much higher uptake of meningococcal vaccine compared to HPV vaccine. So the views clearly were different.
Thank you.
Yeah. Gary? Oh, I'm sorry. I should let Katie do it. I
Oh,
apologize.
that's okay. Gary, you were muted.
Do I have permission now?
You have permission to go ahead.
Okay. I have double permission. This is great. Okay. So it's incredibly encouraging that during the pandemic, when schools were closed down, when there were probably fewer physician visits by folks in the target group for HPV vaccination, that we weren't seeing a significant decline. I'm wondering what that's attributable to.
Well, Gary, my speculation is that since these data focus on teenagers between the ages of 13 and 17, and my speculation is most of them are ended up going to the doctor before school started. And that in contrast to adults, that they actually had interactions with the healthcare system, even though most of them were clinically well. But that's pure speculation on my part.
Yeah, I was just reflecting on the fact that there were significant periods when schools were closed.
Yes,
And
but I'm not sure that people knew that, et cetera. But you are probably, you all are more familiar with this than I am. But and even if the schools were closed, they were still having classes, and there was still some in-person meetings. But let's not go into that more.
Okay, thank you. I'll ask a question while we wait for others to come up. I was really struck by the data showing that that early vaccination for HPV is very important, and that providers, provider recommendation is really important. I don't think, as a parent of a 13-year-old, I don't think that information got passed to me when I was getting my 13-year-old vaccinated, how important it was to be early. Is there still work being done to try to get providers to educate parents more in that area?
Well, there is, but I'm not sure how widely disseminated it is. What I think happens is that there's still a certain amount of what the CDC calls provider hesitancy on the part of some pediatricians. And I think that they don't end up not recommending the vaccine because they don't want to get into long discussions about sexually transmitted infection. Is your child sexually of issues? There is the there is a roundtable on cervical cancer and HPV meets, and there were various representatives. It's the ACS, it's a CDC organized program, and it's run out of the American Cancer Society. But Katie, your question is very well, very well put.
Thanks. We have Gary, do you have another question, or should we go to the one in the chat? Okay, all right. We have one in the chat from John Olson. He says, in the HPV versus meningococcal vaccine, rates in the US, is there a regional variation? And does that mirror similar vaccine rates for STI incidence, vaccination, and sex education availability?
At the risk of John, thanks very much for your question. At the risk of oversimplifying, I would say that regionally, there was much faster uptake in almost all states of meningococcal vaccine compared with HPV vaccine. And now that there are school entry requirements in almost all states for meningococcal, the uptake is very high. If I haven't fully answered your question, I apologize, but you can look back at MMWR every year publishes the vaccine uptake among teenagers 13 to 17, and they have, the data for the different, by state data for the different vaccines.
Okay, I have another question. So I was curious about the difference between a viral type and a viral variant, and if you could clarify
Sure.
at what point within SARS-CoV-2 could we actually see different viral types, or is that possible?
Okay, what viral types are generally defined with SARS-CoV-2. They have been defined genetically, and basically they all are binding to the same receptor on the cell, and so they're simply designated to be variants. With HPV, HPV has been defined genetically also, but once there's a certain amount of variation, and it's defined according to the main structural viral protein and the homology, the phylogenetic relationship, once there's a certain difference, a variant is less than a certain percentage difference, whereas a new type is more than a certain percentage difference. And Katie, where I think it's important is because people, when they see what happens with the SARS-CoV-2 vaccines, will the HPV vaccine be protective that was developed, more than 15 years ago? Will it still be protective if my child takes it today? And the answer is yes.
Yes.
Because there's not much, there's very little genetic variation that occurs in with DNA viruses. They don't mutate very frequently. Whereas the answer, unfortunately, is, the SARS-CoV-2 vaccines, just because of this antigenic drift, if you will, and very rapid replacement in the population, is a much bigger problem.
Great, thank you. Do you think providers are experiencing that sort of pushback from patients and parents right now?
I don't, Katie, I don't know, because I don't give enough talks, about this, and really haven't asked people. But when I have given talks, people in the audience who are not familiar with vaccines, they are surprised by some of these salient differences between HPV and SARS-CoV-2. So I just wanted to clarify that for people in case that was a question.
Great. Gary, go ahead.
Doug, what are some of the principal types of resistance from parents that we're encountering right now, based on the fact that there's more out there in terms of the effectiveness of the vaccine and the fact that it's no longer just male versus female.
Yeah, and I should, although I didn't specifically say it, the rate of male vaccination now is almost equal to that of female vaccination. I think that in terms of resistance, to me, provider recommendation clearly, I mean, on a population-wide level, very important. There still are myths about people, if they get the vaccine, that it will increase sexual activity. But an easy way to deal with that is to vaccinate kids when they're younger. The vaccine is approved for kids from 9 years of age and up. So, and 2 doses, up through age 14. When the vaccine was very new, you weren't sure what the duration of protection would be, but that's no longer an issue. So there's, if you want to separate the, if you will, the sexual aspects of HPV transmission from HPV vaccination, target 9 and 10-year-olds.
That's a great point. So I have another question about the incidence, I guess, of cervical cancer versus HPV infection, and how, I don't know if I might have missed that on the slides, but how often does HPV infection lead to cervical cancer or any of the other cancers? And are a lot of infections just going undetected in patients so young, and that's why you need to have it, the
Sure.
vaccine
Julie,
administered very early?
That's a terrific question. Let me unpack it.
Sure.
Okay.
Thanks.
First, you can't get an answer to your question in the United States, and that's good news. That's because most women get screened. And most women, if they have dysplasia, it gets treated and that's it. But you can get that information from low and middle income countries where there's almost no high quality screening. And a woman's lifetime risk of cervical cancer is in places like Africa is on the order of 1%, okay, which is enormous. And the risk of getting the risk of getting cancer varies with the HPV type. HPV 16 is the highest risk, and there, if you are HPV 16 positive and you've been persistent, the likelihood of your developing invasive cancer over the next 5 years is on the order of 25%. On the other hand, if you look at those other HPV types that now are in Gardasil 9, but not 18, okay, and not 16, their likelihood of progression is more in the 5 to 10% range. Okay, so that's so there are those type specific or type associated differences, but we capture now with Gardasil 9 about 90% of cervical cancer. Okay, what happened, if you look at the data in Denmark and you see, and the very similar data in the United Kingdom, where they actually use the GlaxoSmithKline vaccine, and in Sweden, where they use the Merck vaccine, the data are really based on Gardasil, okay? And what happens is that you're much more likely to get cancer with a short interval from HPV 16 and 18 than you are from the other types. So even though Gardasil may protect against 70% of cervical cancer, you get this higher protection, closer to 90%, because of the preferential increased incidence of HPV 16 and 18. Okay, but right now it's 90%, and because of that, women still need to get screened, even though they've been HPV vaccinated. Thus far, this has been a theoretical concern about decreased screening, but thus far, vaccinated women don't seem to be screened at a lower rate.
Okay, we have one more comment, I think, or a couple more comments in the chat. Dr. Bradford says, as a gynecological oncologist, seeing these higher rates of vaccination are so exciting. And there's another comment that says, this is not particularly quantifiable, but when I bring up HPV vaccination with students, it's a no-brainer to them, normal, routine, no questions asked, part of their everyday health. As a social scientist, this intrigues me because I think there's a norm here we in health communication can take advantage of. And I think,
yeah, my response, which may be an uninformed response, is that we have the advantage of HPV vaccination, that it has been introduced slowly. The vaccine was approved in 2006, and initially there was low uptake, but it's just been, persistence. And there hasn't been, the showstoppers. Okay. And so it's just I'm not sure that this is getting at the issue of what about SARS-CoV-2 vaccination. SARS-CoV-2 vaccination is qualitatively different because we wanted everybody to take it the day after it was authorized. And so there were just lots of concerns about it, and then it became politicized on top of that. And I actually was very concerned a year and a half ago that HPV vaccination might end up also become more politicized. But thus far, there doesn't seem to be evidence that that's happening.
okay, thank you so much. Well, we're a little after 1, so I'd just like to thank Dr. Lowy again and all of the attendees for joining us. Just a reminder, the next CTR seminar is November 4th from 12 to 1, and that's assessing the food security and health impacts of the COVID-19 pandemic in rural New England with Dr. Meredith Niles and some of her team. So please join us for that. Thank you so much for joining.
Thank you.
Thank you.
Thank you, Dr. Lowy.